Hello, everyone. Um, Welcome to the lecture of sound in medicine. Today, we'll explain what is the properties of sound and what is the application of sound in medicine. The outlines will be physics and the properties of ultrasonic waves, interaction of ultrasound wave with tissues, the components of ultrasound devices, different modality of the ultrasound imaging. The fundamental physics of just like as I said, we will divide into two parts. The first part will be the fundamentals physics of sound waves, which is concept of sound waves, properties of the sound propagation media, interaction of ultrasound with the tissue. Let's start from the wave. Just like a wave is a repeating or movement that transfer energy through matter of space. So any energy you want to transfer it, for example, light is energy. If you want to transfer it, sound is energy. If you want to transfer it, you will use the wave to transfer this energy. So the waves transfer only energy, not matter. Sorry. Only transfer energy, not matter. And waves can be only exist if you have energy to carry. And what types of waves you have? You have two types of waves. You have electromagnetic waves as shown here in the animation, and you have mechanical waves just like as shown here as well. We will consider the mechanical wave or the sound wave. The sound is, as I said, because it's mechanical wave, that means the mechanical energy that propagates through the continuous elastic medium by the compression and the expansion of the particles that compose it. For example, imagine you have a piston like this one here. Okay, when the piston pushing here, what will happen is like a sound pushing, the same idea. The particles will be beat together the same side, named compression, or far away from each other, which is what will be name it compression. So name it expansion or refraction. So compression is when the particles will be close to each other, while the refraction when the particles will be far away from each other, and it will be compression is caused by mechanical deformation induced by the external force. This is the force that we apply, which resultant increase in the pressure of the medium. So when you're pushing like the force, external force, the pressure will be increased, the particles will be close to each other, we name it compression. And vice versa, when the force will be like applied in the inverse way, the pressure will be decreased and the particles will be far away from each other. Okay, and this is the idea of the compression. And here is just example. If you have, for example, a speaker and you have particles in that medium. So as we said before, the sound will be moving only if there is medium. Without medium, the light can be moved without medium with the space, while the sound is moving only with the medium. So this is medium. There is no speaker motion. When the speaker start to move, the particles will go to be close to each other, which name it compression the medium. The speaker then return back to the original position, and then it will be a backwards force applied to the opposite side. So the particle will be far away from each other, and the particle here will be close to each other. So it's just like a refraction of the medium happen. Continuous series of compression and expansion make the sound transfer from one space or from one medium to another. In terms of the waves, in terms of the mechanical wave, just like we have two kinds of the mechanical wave. Two kinds of the mechanical wave. The first one is transverse waves, and the longitudinal waves, the second one. The transverse waves, when the particles is moving upwards and backwards, like up and down. See, when the particles they are moving up and down. Okay, so the compression and just not compression and expansion, just like moving upwards and downwards. This one we name it transfer waves. The compression waves, when the particles moving forwards and backwards. So just like a back and forward parallel to the direction of the wave. This one, we name it as a longitudinal wave. And here you can see this movement here, it's mean compression, or name it longitudinal plane wave. While this one, we name it as a transfer plane wave, is moving upwards and forwards and backwards. How can the sound will be traveled through the medium? It just like, as I said, we have longitudinal transfer waves. The sound is transmitted through gases, plasma, and liquid as longitudinal waves. Through solid, however, it can be transmitted both longitudinal and transfer waves. And from here, you can understand which one is better, or which one is more advantages is longitudinal wave, because longitudinal wave can be the sound can be transmitted via longitudinal wave as in the gases, plasma, and liquid as well, and solid as well, all of them. While the solid is just like make the transfer waves happen to it. So the advantages of this lead out to advantages of longitudinal wave. Longitudinal wave propagate in all kind of materials. Okay, solid, gases, all the kind of material. While the transfer waves only propagated through the solid materials. Due to different types of oscillation, transfer waves travel at low speed. Then we have the sound wave, or the properties of the sound wave. The way the sound is just like when the sound is a travel, okay, just like as we said, series of compression, which is the up and expansion, compression and expansion. The distances between two compressions, we name it wavelength, lambda. Okay, the amount of the compression, which is the amount, the highest of the wave, we name it amplitude of the wave. Okay, the distance for one compression and one expansion from here to here, we name it as lambda, as a frequency. Okay, so and this is lead you to understand that if the wavelength is just like if I'm writing it, the velocity of sound C equal lambda time V. When the frequency, when the wavelength increase, what happens to the frequency increase? The frequency will be decrease. Okay, and this one, and when the frequency decrease, the lambda decrease. This one give you all the time constant velocity. Okay, give you always constant velocity. So that means the velocity is not depend on the wavelength and the frequency, because the frequency increase, the wavelength will be decreased, and so on. The range of the frequency, it will be depend on other things. We will talk about it later. The range of the frequency we have from 0 to 20 hertz, we name it infrasound. From 20 to 20,000, it will name a doable sound, or the speech or the music, for example. More than 20,000, it will be ultrasound. Okay. For the medical ultrasound, they are using 1 to 20 megahertz. Okay, the golden rules for the waves. As I said, the velocity is just like the speed of sound that transmit, or the distance traveled by the wave per unit time, and equal to the wavelength divided by period, or the wavelength multiplied by what? By the frequency. Does that mean the speed depend on the frequency or wavelength? No. The speed of sound is depend on the propagation medium, and it varies widely in different materials. And this is lead us to understand how can, and this is important for the ultrasound imaging, what is the main parameters that make influence or affect the velocity of sound? We have two things, density and compressibility. The density is the mass of the medium per unit volume. Okay, if you have any container here, this is container, we have particles, a lot of particles here. Okay, we'll say this container have high density. I will say just high density. While if you have container have high D, so mean density. Here it will be low D, low density. Okay, and just like is said, if all other physical properties of the medium are maintained, this is important. When I'm saying all physical properties are maintained and change, then the increase of the density will be decrease the rate of the sound propagation that medium. That's mean a less density material has higher speed of sound than a less density material. A less density material have higher speed of sound than the less density material. For example, the dry air and the humid. Just be careful. We are talking about only if the volume, if the density is changed. So all the other physical properties are unchanged. Okay. Okay. What about the compressibility? The compressibility is just like here. Let me show you. The compressibility, I will leave this one as high density, low density. But what is the compressibility? When the particles are close to each other, we name it high density. The same idea, we will say it's low compressibility. What does mean? The compressibility is just like how can we decrease in volume when the pressure is applied to the material? Okay, for example, you have any ball, a solid ball. If you are pushing, if you are applying pressure on it, are you changing the size of it? No, you cannot change the size. That's mean this one, it will be have a high, a low compressibility material. If you have a ball, but the ball is not ball, something, a paper, okay, a paper, and you are apply a pressure on it, you are changing the volume of it or not? Yes, you are changing the volume of it. So this means the paper have a low compressible, high compressibility material. Okay, so anything that have high compressibility material, that's mean, for example, the air have high compressibility material, the bone have low compressibility material, and so on. Okay, depend on the on this formula. They said when the material have high compressibility, the speed of sound will be what? Will be low. While the bone have higher while the bone have higher speed of sound. So when the compressibility decrease, the speed of sound will be increase. This is the idea. So we are confused now. Why we are confused? Because just like because of the if you have a material have compressibility and the density together, both of them. Okay, and the particle substance are independent. A change in the density is often coupled with a large or opposite change in the compressibility. So that's mean, for example, the bone. When I say bone, the bone have high density material, high D, and what? And low, what we name it, low compressibility. While the air have low D and high compressibility. So which one have more effect? Because the compressibility varies more rapidly, it's become the dominant factor in the velocity. That means what? Any material have high compressibility, it will be have low density, low velocity. Any material have low compressibility will have high velocity. So overall, the effect is commonly summarized by the statement that as density increase, the velocity of sound will be what? And the medium will be increased. This is why you will understand the velocity of sound in air is 333. The air have low density, while in the bone, which is have high density and low compressibility, it will be like a 4080. Bone is denser than air, but compressibility is the key factor that it will be making the velocity, because bone is less compressible than what? Than the air. What about the liquid? The liquid is just like the differences in compressibility and density in terms of the liquid will be cancel each other. So there is no effect. For liquid in general, density and compressibility offset each other. And that means different type of liquid will be transmit at nearly the same velocity. So you will see like a different types of liquid, blood, water, something like this. You will see them, they have the same, nearly the same velocity. Why? Because the compressibility and the density, they are cancel each other. And the transmission of the sound, soft tissues, for example, in our body, we have hard tissues like bone, teeth. We have soft tissue. We have soft tissue like tissue like muscles, like fat, tumors. All of them is soft tissues. And you have liquid like water, spinal fluid, water, blood. So the soft tissue is considered as liquid. And of course, we have air, for example, the air in the lungs and this in the colon as well. So the soft tissue is considered as a liquid, behaves similar to the liquid, and that means the velocity of the soft tissue will be nearly to the what? The velocity of the liquid. Okay. In general, because their compressibility is low, more density material, solid, have greater velocity than the less density material, liquid or gases. Okay, and if you see the table here, if you see the air is 330 because have a high compressibility, the velocity is low, while the bone, you will see them 3,500, which is have a high compressibility. Okay, while the water, blood, fat, muscles, if you see them, they are close to each other because the compressibility and the velocity, compressibility and the density, they are cancel each other. Let me end up with this section, and I will record the other one for the another section. Thank you very much.